Hi, everybody. We're going to do BB.8, which is the solving a quadratic equation by factoring. This is one of my favorites. I always say that, but this really is. I really love solving by factoring. So here it is. We are looking for the factors for x squared plus 6x minus 16 equals 0. Because if we can factor it, we don't have to use the other methods for solving this. And the way I like to think of factoring is I like to do my stack method. So I like to write my quadratic, x squared plus 6x minus 16. And I'm going to write down the two x values. X times x gives us x squared, doesn't it? Now, the nice thing is that both of these are the same, which means it doesn't matter where I put the two factors. Now, there are several factors for 16. I have 2 times 8, and 4 times 4, and 1 times 16. These are the ways in which to factor 16. But if I read this trinomial backwards, the way I'm supposed to, I want a product of 16 and a difference of 6. And I want the bigger one to be positive. All of these things give us clues as to how to put these together. Now, which one of these pairs has a difference of 6? Well, this is the one we're looking for, the 2 and the 8. So I like to write my 2 and my 8. Now, what I want you to see is that if I cross multiply these, I get 8x and 2x. Because what I'm doing is I'm multiplying my inner and outer terms, if you were thinking in terms of FOIL. Now, I want the larger number to be positive and the smaller number to be negative so that I get a positive 6x when I add these. That means that I need a positive 8 and a negative 2, and that does give me my 6x. And so the factors are x minus 2 and x plus 6 equals 0. And I'm sorry, x plus 8, geez. X plus 8 equals 0. So there's my two factors, and all I want to do is make them 0, because if these two factors are multiplied together and give me 0, one of them has to be 0. So either x minus 2 equals 0 or x plus 8 equals 0. And solving this gives me x equals 2 or x equals negative 8. These two solutions will make a negative 8 makes this 0, a positive 2 makes this factor 0. So those are my two zeros. I don't go through all these steps, but be aware a common mistake is to go directly from here and to think that the solutions are negative 2 and positive 8, which they're not. I recommend that you don't oversimplify it, but that you do make it a little faster. So our two solutions are 2 and negative 8. And they want me to put a comma in between if you read the directions. And there's my two solutions, and I can move along. All right, I'm going to go a little faster maybe on this one. Now, if you haven't practiced this, you can go back and look at the section that came before, which is they already factored them for you, so you don't have to do the factors. Now, this time, I have a product of 24 and a difference of 2. 24 has a lot of factors, but there's only one of them that has a difference of 2. So let's write down the factors of 24 just for practice. So I could multiply 1 times 24, which has a difference of 23. I could multiply 2 times 12, which has a difference of 10. I could multiply 3 times 8, which has a difference of 5. And I could multiply 4 times 6. And the 4 times 6 has the difference of 2. Now, with practice, you will notice, without writing them all down, that this was the one you were looking for. And I'm going to go ahead and do this one last time. This is y squared plus 2y minus 24. And I want to factor it. I'm going to go ahead and write the equal 0. And I want to factor this into its two parts. I like to stack them. Some people don't. It doesn't matter if you stack them or not. I'm going to use my 4 and my 6. It doesn't matter where they go. said 6. Now, the reason it doesn't matter whether I put the 6 or the 4 on the top or the bottom is because the y and the y are the same. If I had had a leading coefficient, it makes it more complicated. I want these numbers, the 4y and the 6y, I want them to add up to positive 2y. So the positive goes with the larger. Positive 6y and a negative 4y. That means the negative has to go with the 4 and the positive has to go with the 6. Now, these are the factors for this quadratic trinomial, and these are equal to 0, and I want to zero them out. Well, in order for this first one to be 0, I need a positive 4. For my second one to be 0, I need a negative 6. And those are my two solutions to this equation. Now, there are other methods. You could use graphing, you could use quadratic formula, you have other possibilities, but this is so far and away the easiest method that that's the way you want to go, okay? So trust me, gotta move out of the way of my friend here so he can see over my shoulder. There they are, and let's try another one. Let's see here. Okay, notice I've got a 20 and a 21. There's a big clue there. When the middle number is very large compared to the last number, the chances are that you're going to multiply 1 times 20 instead of the 4 times 5 or the 2 times 10 and so on. And it does happen to be 1 times 20 does give me 21. The question is, we have a product of 20 and a sum of 21. And the larger, of course, is positive. Of course, they're both positive. But hopefully you can see it. With a little practice, it's going to be a lot easier to see these. I'm going to go ahead and write it one more time. I prefer, again, to stack. I need a 20 and a 1, and that is going to give me my 20y plus 1y is my 21y for my middle term. Now, how do I know that the first terms work? Well, I chose them that way. You see, y times y is my y squared. And my 20 times my 1 is 20. So this is 21y for my middle term. These are my factors. Now, the reason that factors work so well is that when y plus 20 is 0, then it doesn't matter what the other factor is equal to. Let me show you what I mean. This is the last time I'm going to do this, I promise. Negative 20 will give me 0 for this first pair, but when I put a negative 20 in here, it gives me negative 19. Well, look what happens. I put the negative 20 in for y, and I get 0 times negative 19, which is 0, isn't it? But when I put in negative 1, if I put negative 1 into both of these, I get 19 times 0, which is 0 again. You see, it doesn't, as long as one of them is 0, it doesn't matter what the other one is. That's an important idea. Anyway, I have negative 1 and negative 20. And those are my solutions. We also call them roots or zeros. Okay, looks like a very similar situation. Hopefully you can see that we're looking at j plus 18 times j plus 1 equals 0. And my solutions are going to be negative 18 and negative 1. That's it. Done. That easy. Let's see if we have a better one this time. Okay, now this one's a different situation. This one has z's, and I can take the z out. So what I'm doing is undistributing the z. And I know that if I take the z out, I have a z left inside plus 26. All I did was factor a z out of each term. It's the opposite of distributing. You can see if I distribute the z, that I get the z squared plus 26z equals 0. Again, if you don't know why I'm getting 0 for one of my solutions and negative 26, you might want to go back and practice without the factoring, but it's up to you. Obviously, if I want the first term to be 0, then z is equal to 0. And if I want the second term to be 0, I have to have negative 26. And those are my two solutions. And this one is going to be a little bit different than the one where we had the double positives. In this case, we want to get a negative 23. Now this happens to be a prime number, which means the only possible factors are 1 and 23. So I've got G and G, I've got 1 and 23, and we know that the bigger one has to be positive. A very common mistake is to put the answers as 23 and negative 1 and skip this step. Probably not a good plan at first, because I mean, I could probably get away with it, but I wouldn't recommend it. I know that I need a 1 G equal to 1 to make this one 0, and I know I need a G equal to negative 23 to make that one 0. So those are my two solutions, negative 23 and 1. If you can see why someone might choose negative 1 and positive 23 as solutions, need to be careful of that, okay? Let's see what we get this time. Okay, very similar type of problem. We're looking at x minus 21 times x plus 1, which will give me my negative 20 in the middle. And so I'm looking at 21 and negative 1. Oops. There they are. Those are my solutions, 21 and negative 1. Looks good. Okay, we're going to take out the s. Take out the s, and we get 31s minus 44 is equal to 0. So either s equals 0 or the 31s minus 44 equals 0. I don't like that s because it looks too much like a 5. In order to solve this, we have to add 44 to both sides. And we get 31s is equal to 44. And then we divide by 31. And if possible, you can reduce, but we can't because 31 is a prime number, even though 44 is 4 times 11 or 2 times 22. We can't simplify the 31, so we're done. S is 44 over 31. It does say improper fractions are fine. You don't want to try mixed numbers in this. So we have 0, and we also have 44 over 31. Now in the future, I probably am not going to go through all those steps like this. Again, I'll just simply do it in my head. I'll add the 44 and divide by 31. Now let's see if we can get a better one this time. Okay, now this is a much more interesting type of problem. The first thing you want to do is see if you can take the 3 out, because that's going to make it easier for you. But 13 is a prime number, so there's no 3 that you can take out. So we know we're talking about, and I'm going to go ahead and write it out for you, 3t squared minus 40t plus 13. Now there's a couple of things that you want to pay attention to. One of them is that last number is positive and that middle number is negative. That means that both of these are going to be negatives, because when we multiply them together, we have to get a positive 13. So I already know the only way that I can possibly get a positive 13 and a negative in the middle is negative 1 times negative 13. A little practice goes a long way on these. But I'm going to go ahead and just do the factoring kind of slowly here. I have a 3t and I have a t. Now, that's the first pair. And the reason is because I have 3t squared. So I know the only way to get that is 3t times t. Now, I need to get a 13 at the end. Well, the only way to get that is 13 times 1 or 1 times 13. And it does matter which way you go. Because if I put the 13 and the 1, then I get 13t and 3t, and when I add them, I get 16t. That's not what I want. I want a bigger number. That's why I put the 1 and the 13, and look what I get. 3 times 13 is 39, and 1 times t is 1t. And when we add those together, we get 40t. Now the problem is we want to get negative 40t, don't we? So we don't want positives, we want negatives for both of those. And that's why I have negatives on there. And there we go. These two factors are equal to 0, and I can solve them separately. I have 3t minus 1 equals 0, or t minus 13 equals 0. This one, to solve it, we have to add 1 to both sides and divide by 3. And I'm just not going to do all that. I'm just going to add 1 and divide by 3, and I get 1/3. For this one, I just add 13, and I get 13. So my two solutions are positive 1/3 and positive 13. 1/3 and 13. And we're done. That's it. I hope you guys will practice this. It's not as hard as it looks. All right. Again, we're going to look and see if we can take the 3 out of everything. We can't. So we're going to do some factoring. We've got a 3x squared plus 8x minus 16. Now this one's a slightly different situation because we are going to multiply and get 16, but when we take the difference, we're going to get 8, aren't we? So this time we're looking at different signs. So I'm going to start with the 3x and the x to make the 3x squared. Now there's lots of ways of getting 16. I could multiply 1 times 16, I could multiply 2 times 8, or I could multiply 4 times 4. Now remember, the difference needs to be 8. And a lot of students are going to look at this and they're going to say, well, the difference of this is 0, the difference of this is 15, the difference of this is 6, so it's not factorable. But what they're forgetting is that one of them is going to get multiplied by that 3. So you need to remember that the difference is going to be 8 after you multiply by 3. If I do 2 and 8, 2 and 8, I'm going to get 8 and 6 for my two middle terms when I cross multiply. And the 8 and the 6 have a difference of 2. If this number had been 2, then I would use 8 and 2. If I go the other way, 2 and 8, I get 24 and 2, which has a difference of 22. Way too big. Since it's too big, chances are I'm going to go with the 4 and the 4. Now, I know this takes time and practice, and it's hard to see, but look what happened. 3x times 4 is 12x, and 4 times x is 4x. And these really do have a difference of 8. Now I know I need a positive 8x. So I need a positive on the 12x and a negative on the 4x to make that work. This one has to be the positive, and this one has to be the negative, so that I get the negative 4x and the positive 12x, which gives me my 8x as my middle term. A lot of people are going to say, oh man, there's got to be an easier way. And there is. If you happen to have a graphing calculator handy, you can just stick this into your graphing calculator and calculate the zeros. That'll work. You can also put it into quadratic formula, which by hand is fairly complicated. But there's other reasons for learning how to factor than just being able to solve them. And I hope you'll practice it a little bit. Hopefully you can see that this one is going to, I'm going to write it 3x minus 4 equals 0. So my solution is going to be positive 4 over 3 because I'm adding 4 and dividing by 3. So I'll just put the plus 4. And divide by 3. I won't do this again. X equals 4 over 3. So one of my solutions is 4 over 3. And my other solution is going to be negative 4, isn't it? And that's it. You're done. Come on. All right. I like these. I know you guys don't, but I like them. 3j minus 10j minus 13 equals 0. And we want to get the 3j, sorry, j, and a j to get 3j squared. And I want to get a minus 10 in the middle. So I want a product of 13 and a difference of 10. And I want the bigger one to be negative. Well, look at this. There's only one way to get 13. 1 and 13 or 13 and 1. If I do 13 and 1, I'm going to get 39 and 1. That is not going to have a difference of 10. So clearly I have to do the other way. 13 and 1. Now I get 3j this way and I get 13j this way. I'm cross multiplying, by the way. Now I know that one of them has to be negative and one of them has to be positive so that I get a negative 10j in the middle. The negative was with the 13 and that gives me negative 13j, and 1 times 3j gives me my 3j, and there we are. And my solutions then are going to be the zeros for these pair of factors. This first one is going to be 13 over 3. The second one is going to be negative 1. Need a space. And there we go, 13 over 3 and negative 1. Okay, in this particular one, it's a lot easier to take the 4 out to begin with. So I'm going to factor out a 4. Now I talked about this when we were doing factoring. And I just want to mention something here. 4t plus 3 equals 0. A common practice is to divide the 4 out before you ever start because you don't need the 4. I'm not going to do that because when you do that, you tend to forget about it when you're factoring. And you want to remember that 4 is one of your factors. Now, you could divide the 4 out and it would just be gone and you wouldn't have to worry about it and it wouldn't be a problem. But hopefully you can factor this pair into its 2 parts. We want a product of 3 and a sum of negative 4, which is t minus 1 and t minus 3. If you need to practice that a bit, go ahead. Again, I could have divided out the 4 and the 4 would be gone. Because the 4, there's no way it's ever going to be 0. This could be 0 if t equals 1, and this could be 0 if t equals 3. Again, a common mistake is to try negative 1 and negative 3 as solutions, and they're not right. This is going to be 1 and 3. Those are my 2 solutions. Okay, this one we're going to take out a v, aren't we? So we take out the v, and we end up with v minus 16 equals 0, and we get 2 solutions. And I got a phone call, so I'll pause.